Today's video is 3.7 graph features, the x and y intercepts. So you can see here that I've already put in what x and y intercepts are. And today we're going to learn how to, so go ahead and write that in the blank spot on your notes. And then today we're going to learn how to identify x and y intercepts from a graph and algebraically, and compare x and y intercepts of two functions represented in different ways. So the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. And we discussed a little bit on the last time about the x-intercept being where y equals 0, where it crosses the x-axis, and being the 0 of the function. So for this graph, that would be down here. So this is the x-intercept down here. And right there, x equals 8. Another way that you might be asked to write this is as an ordered pair, which for this one would be 8, 0. So when you have an x-intercept, the y is always 0. And then the y-intercept, which we didn't talk about, but it's the same kind of thing. You go to the y-axis, and where does the graph cross it? So that's the y-intercept. And for this one, that would be y equals 6. Or if you need to write that as an ordered pair, that would be 0, 6, because the x is 0 when you're on the y-axis. All right, so you need to remember that x is 0 when you're finding the y-intercept, and y is 0 when you're finding the x-intercept for what we're going to do down in the bottom section. So right here, if you're asked to identify the intercepts from the graph, it's kind of like what we did Monday with the x-intercept. So the x-intercept there is 2, but you also need to do it with the y-intercept, which for this one would be down here at -1. And then for number 2, we've got that the x-intercept is 0, but we also can see that the y-intercept is 0. So if the line crosses through the origin, both the x-intercept and the y-intercept are going to be 0, because that point right there is 0, 0. So that's where those numbers come from. And then if we have a vertical line like we do in number 3, we only have an x-intercept. So here x is 2, and y does not exist. So that is all you can have there for that, because we just cross the x-axis. It's never going to get over there and cross the y-axis. Now, if I put a horizontal line in down here at the bottom, we're going to kind of pretend like that vertical line's not there and just look at this horizontal line. For this one, we only have a y-intercept, so we can see that y equals -4. But the x would be no solution or no intercept, because it's never going to just jump up there and cross that x-axis. So that's a little bonus one there for a horizontal line. Now, if we need to solve these algebraically, and we're going to use for both finding the x and y axis this 2x minus 3y equals 18. So we're going to use that for both the x-intercept and the y-intercept. So what that means that you need to do is you need to make the y 0 if you need the x-intercept, and then to find the y-intercept, you're going to make the x 0. So we're just going to substitute, kind of like we did on the last lesson where we were doing f of x and having to find where that x-intercept was. It's the same concept. So for this one, we're going to have 2x minus 3 times 0 equals 18. And so we replace that y with 0. And so then 2x equals 18 is the problem we're actually trying to solve, because 3 times 0 is just 0, and that's not going to affect our answer. So we can just, it's kind of like that zeroes out, and it eliminates it from our problem. So then we're going to divide both sides by 2 to get x by itself, and 18 divided by 2 is 9. So this point right here would be 9, 0. To find the y-intercept, we're going to do the same thing, only this time we're going to make the x equal 0. So we're going to have 2 times 0 minus 3y equals 18. And just like before, we don't need this 2 times 0. That's just 0. That's not going to change our answer in any way. So we can just exit out and move on to finding the y. And so you can see here we've got negative 3y equals 18 left. Don't drop that minus from the 3. Okay, that's an important part of our answer, so you want to be sure and use it. So then we're going to divide by negative 3. And y equals negative 6. 18 divided by negative 3 is negative 6. And so that point would be 0, negative 6. Now, I'm just going to use this graph that's already here so that we can kind of talk about what this would look like if we graphed it. So we know we would have, well, we don't have 9 or 6 on here, so that's going to be hard to do. So let's pretend we're counting by 2s on this. So like this would be 2, 4, 6, 8, and then 10 up here. And so then down here we would have negative 2, negative 4, and so on, okay? So if we had to plot the point 9, 0 on the x-axis, and we're counting by 2s, we'd have 2, 4, 6, 8, 10. So 9 would be between those two. And then 0, negative 6 would be down here. So we would have 2, 4, 6. So that would be negative 6 right there. And so then the points are the intercepts for this line on that graph. So that's how that would look if we graphed it. Okay. So we're not going to graph any more of these, but we are going to do some more practice with finding the x and y intercept using algebra. So the x-intercept means that we put in a 0 for y and then solve what's left. So we've got 4x equals 12 left. 0 we don't need. We're going to divide by 4. So x, oh, that's kind of messy. X equals 3. And then for the y-intercept, we're going to do the same process, only we're going to make the x equals 0. So 4 times 0 is just 0. We don't need that. We have negative y equals 12. Don't forget, negative y means that you need to divide by negative 1 so that it can be positive y. And 12 divided by negative 1 is negative 12. X-intercept on the next one, we're going to take out the y and put in a 0. And so x plus 0 is just x. So that one is just negative 1. Y-intercept is going to be the same thing, because when we take out the x and put in the 0, then we're just left with y equals negative 1. And as soon as that variable is by itself like that, you're done. That's the answer. So that one is basically like a no-step problem, because the answer is automatically there when you substitute in that 0. Now notice number 6 and number 7 have y equals in front, so that is going to change the way that we solve it a little bit, but it doesn't change what we do. So we're still going to put in 0. So this looks very similar to the ones we did in the last lesson, where we had f of x equals and whatever the function, and we made the function equal 0. So you're just taking that y out, putting in a 0, and then solving the problem. So if we subtract the 5, because we're trying to get x by itself, 0 minus 5 is negative 5. And so we have negative 5 equals negative x. And then just like in number 4 up here, we need to divide by -1 to make that x positive. So we have 5 equals x. Now the y-intercept version, when y equals is out front, is actually super simple, because when you substitute in that 0, it's just going to be 0 plus whatever number was already there, and so it's 5. So you probably remember seeing this formula, y equals mx plus b, and that's the slope-intercept formula. And hopefully you remember that b is always the y-intercept. So you can see that 5 is the y-intercept for this problem, and 5 was b. So that last number is always going to be the y-intercept when the equation starts y equals, and only when it starts y equals. So x-intercept here, same as before, 0 equals 1/2 x minus 8. We're going to add that 8 back over there so that we have 8 equals 1/2 x. And then you can divide by 1/2 or multiply by 2. So 8 divided by 1/2 is 16. So 16 equals x. And then the y-intercept, just like in the previous one, you're going to have y equals 1/2 of 0, which is 0, and 0 minus 8 is just -8. So it's still, just like before, it's that b part of your equation. Okay? All right, and then the last thing is finding them from a table, which is probably the easiest part of this lesson. So the first thing is you have to think about what is x when y is 0 for the x-intercept, because the y will be 0 because it's on the x-axis. So y is 0 here. So that means that our x is -3. Our x-intercept is -3. And then you're going to do the reverse of that for y. So in y, you're asking, okay, what is the y when x is 0? So here x is 0. So that means your y-intercept is -2. And so we're just going to go through those quickly. I'm going to ask the question like that. So what is x when y is 0? X is -5 when y is 0. What is y when x is 0? Y is 1 when x is 0. Number 10. What is x when y is 0? Well, x is 1 when y is 0. What is y when x is 0? Y is 2 when x is 0. Then the last one, what is x when y is 0? It's -3 right here. And then what is y when x is 0? And that's 6 from right here. Okay, so that's all of that. And then your delta math, you're going to have an equation, and then you have to compare it to either a graph or a table. Let me know if you have questions.